Lesson 3-2, Example 4. Our objective is learning to estimate decimal sums, differences, products, and quotients. And here we have a series of numbers, 7 and 86 hundredths, added to 36 and 97 hundredths, added to 5 and 40 hundredths. And if another way to look at this and think about some estimation is to think, well, what if I know a range? And a range just means what's the smallest possible, what is a smaller number, something that's under the exact number, and something that's over the exact number. Our exact answer will fall somewhere in between. So we have an underestimate, and we have an overestimate. And our exact answer falls somewhere in between. This one's going to be too small, this one's going to be too big, and our exact answer will fall somewhere in the middle. So how might we do that? Well, one of the things we can use is called front-end estimation. And front-end estimation means that we're looking at these numbers and we're just looking at the whole numbers. So, if we have 7 and 86 hundredths, and we have 36 and 97 hundredths, we have 5 and 40 hundredths, when I'm doing front-end estimation, I'm ignoring the decimal piece, I'm just looking at the whole numbers. So it's essentially like I'm ignoring that, and I'm ignoring that. So this becomes 7, this becomes 36, and this becomes 5. And I can add those up, and I'm going to come up with 48 with that. Now, these things that I ignored, these are all parts of a number, parts of a whole. So because I dropped off all those things, this number right here, this estimate, is going to be my underestimate. This is too low. We know that our exact answer is going to be something larger than 48. But let's see now if we can find our overestimate, the one that's too large. So let's take a look at these little pieces that we dropped off. I'm just going to look at that 86 hundredths, that 97 hundredths, and that 40 hundredths. And now I want to look at this and think, okay, what can I get it close to? I'm going to try and get it to the nearest whole or the nearest half. So either the nearest whole number or the nearest 5/10ths there. Well, 86 hundredths, that's pretty close to one whole. And 97 hundredths, very close to one whole. 40 hundredths, well, that's pretty close. This 4 here, if I go up another tenth, I'm going to end up with 50 hundredths or 5/10ths. So I'm just going to round it again to my nearest 5/10ths or nearest 50 hundredths. And if I add that up, I end up with 2 and 50 hundredths. And that by itself is not my overestimate, because remember that these numbers here were attached to these whole numbers over here. So we rounded all of these, this rounded up, this rounded up, and this rounded up. So now we're going to bring it together with our underestimate. And 48 plus 2 and 5/10ths is going to be 50 and 50 hundredths. This is our overestimate. Because these all rounded up, okay, this makes this our overestimate. This is going to be larger than our exact number. So what we can say for sure, we don't know the exact number, but what we can say for sure is that our range is from 48 to 50 and 50 hundredths. Again, this is our underestimate, this is our overestimate, and our exact number is going to be somewhere between these two numbers. And for a lot of things that we do, when we want to do just quick numbers, we want to get an about, this is oftentimes good enough.